number 5c on the Review 2 worksheet. So this one here is asking for the graph of x square root x plus 3, and we want to find local min and max values, and we want to know absolute min and max points, so we're going to need a candidates test. So I'm going to do the graphing part of this as well, although it didn't necessarily ask for that. So there's my equation, there's my function, and I'm just going to make sure I put my domain in here so I don't forget. So within that domain I need local min and maxes and absolute min and maxes. So I'm going to first of all solve for zeros. Not that I really need the zeros to answer the question, but to graph this, I'm going to graph this as well. So in addition to just answering the question, we're also going to take a look at this graph. So to solve for the zeros, the zeros are going to be at x equals 0 and negative 3. Okay, so then that we're going to find the derivative, so we can do our slope chart, and we end up with square root x plus 3 plus x times 1 over 2 root x plus 3. Okay, so there's our derivative. We're going to set that equal to 0 and solve this. So solving this, I'm just going to move one term to the other side, negative x over 2 root x plus 3. And I could solve this algebraically by cross multiplying. So negative, this is going to be 2x minus negative, so I'm going to add x to both sides, so I'm going to end up with 3x plus 6 equals 0, and that gives me x equals negative 2. So it looks like I have a local min or max at negative 2. So I'm going to do my slope chart here, and drawing me my slope chart, negative 2, I've got a restriction at negative 3 and an endpoint at 3 as well. So my derivative is going to be 0 here. If I test my derivative at negative 2.5, okay, so f prime at negative 2.5, I'm going to end up with positive, negative, well, let's see here. So we're going to have to calculate that, so I'm just going to plug it in. So this will be square root of 0.5 plus negative 2.5 divided by 2 divided by square root of 0.5. Okay, let's see here. Okay, so I end up with negative. So this is going to give me a negative slope. So on this side, it's going down. It's going to be a 0 slope here. Testing slope on the other side, so I'm going to do f prime of 2.5. Okay, and that's going to, when I type that into my calculator, I get a positive value. And so my slope is going to look like that. So that point is a local minimum. Okay. Now, if I were to graph this, the graph's going to look like this. So I've got a couple points here. I've got zeros at 0, negative 3, and 0. Okay, I know I have a point at negative 2. Okay, so I'm just going to put my xy, so negative 3, 0, negative 2. When I plug negative 2 into this equation, I'm going to end up with negative y equals negative 2. 0, I get 0, so negative 2 here. That's going to be a local min. Now when I test this, I also have to check the endpoint. I know it's going to go down, up through here, and then it's just going to go up. Okay, so I'm just going to draw that over here a little bit. So I know the graph's going to go like this, hit the minimum, go through the 0, and it's going to go to some point here. So at x equals 3, y is equal to plug it into my original equation. It's going to be 3 times square root 6. 3 root 6. So 3 root 6 is approximately 7.3. Okay, so that's what my graph looks like. I've done my candidates test. I can see my local min, so that represents a local min. And this represents here, this is my absolute max. And I can tell that, I didn't actually draw the graph. I can see from my, this is local and absolute min. Because I can tell from my candidates test, there's my lowest point and there's my highest point. Okay, so this is what my local mins and or my absolute min and maxes look like for this problem.